Well, I'm back. I got my vitamin water. What are we talking about? That's right. Oh, that tastes good. We're talking about solutions. Today, though, what we want to talk about is electrolytes and non-electrolytes. And have I got a story for you? Woo-hoo! I'm going to tell you an interesting story about my life. So stay with me. We'll see you. So today we want to talk about electrolytes, suspensions, and colloids. Now, you've probably heard the term electrolytes before, but not like today. Today we're going to learn about electrolytes and what they are from more of a scientific perspective, and then probably talk about it from the perspective that you understand. All right, first of all, let's do a couple definitions. First of all, an electrolyte is a compound that conducts electrical current in solution. So, for example, if I have a light bulb, and actually you're going to do this demonstration in class. I thought about doing it on the podcast, but I think it's better if you see it live. So if you take a power source, some power source, have a couple electrodes, you stick them together, boom, if you connect the wires, the light bulb lights up. Cool, right? You can then stick it into some solutions. So this is a solution, and some solutions will leave the light bulb turned off. Some solutions will turn the light bulb on. Those that turn it on are called electrolytes. Isn't that easy? All right. Why does this happen? The answer is because you have dissolved ions. Now, let's recall for just a moment, what is an ion? An ion is a charged particle. So like Na positive and Cl negative. If you recall the picture from the last podcast where the sodiums were surrounded by the water and the chlorides, when you have an ion with a charge floating around in the solution, so floating around in this solution, it will conduct electrical current. Because, why? You must say something about ions dissolve. Now, when things dissolve, dissolved, ions, when things dissolve, they don't always make ions. They do sometimes and sometimes not. Okay, here's a good picture right here. So, for example, here is sodium chloride dissolved in waters. Notice that they have charge. Everybody say charge. Good. They've got a charge. So if they've got a charge, then they make an electrolyte in this picture. Now, but if I were to dissolve sugar like the vitamin water that I have, there would be no dissolved ions. And that is considered a non-electrolyte. It could dissolve, but there is no substance. There are no dissolved ions. So in a non-electrolyte, it's a compound that does not conduct electrical current because, why? Because there are no ions. Now these are sugar molecules right here that are dissolved, but they are just sugar molecules. Notice they have no charge. They have what? That's right, no charge. All right, and you can see a better picture of it right here, I guess. All right, I'm going to mark that up. There is also, however, a variety of substance called a weak electrolyte. Electrolyte. And this one partially conducts electrical current. So an example of this would be a particle like this, where some of them break apart and some of them don't. All right. Actually, this shows them all breaking apart. What you should have is a bunch of, when you dissolve them, a bunch of them that don't break apart. So only a portion of them break apart. And actually what happens there pictorially, why only a portion break into ions. So that's the why. Okay? There's also a couple more terms. A lot of terms in this particular first part of this unit. What's hydroscopic? Salts that remove moisture from the air. Okay, so if I have a particular salt, some particular substance right here, and it takes moisture there, it's considered to be hydroscopic. Hydro, that's a typo. Hydroscopic. Deliquescent is something that's so hydroscopic, that's got a typo, that they become wet when exposed to moist air. So there are some substances, in fact, sodium hydroxide is a classic example. If I take little pellets of sodium hydroxide, they're actually like little discs type shapes. What's going to happen is the water from the air is going to dissolve the sodium hydroxide. If I had this on, say, a scale, if this was on a scale, you know, I'm trying to draw a scale. I'm not doing a very good job. If this was on a scale, it would get heavier because it's going to take the water out of the air. So, well, here's a picture of it. It's not the most clear picture. Here's sodium hydroxide, and now you can kind of see barely right here, a small amount of water as it evaporates. Okay? Electrolytes and non-electrolytes, this is that experiment I was telling you. Notice that the light bulb is off. All right, and this is actually a demo that we're going to do in class, and it's one of the things you have to do. So we'll talk about that in more detail then. So leave some space on your page for this. Okay? All right. More on the demo. Yeah, actually this is what the demo, you're going to have substance, if it's conductive or whether it's an ion. So this is what you're going to do if you want to pause and set up your demo table, and then you'll have to explain it to your teacher. All right, and here's kind of the classic picture. No bulb, light bulb, kind of if you can see this, it's a little hard to see, but the light bulb is partially on. All right, now let me tell you a story about electrolytes. Okay, that's me. Yeah. That's me running a triathlon. Many of you know that I do triathlons. And in triathlons, you swim, bike, and then you run. And I was doing a particularly long race one day. It's called the Ironman Triathlon, where you swim 2.4 miles. I know that sounds like a long ways. And then you bike 112 miles. I know that sounds like even a longer way. And then you run 26.2 miles. Yeah, that's a long ways, right? Well, I happen to be doing this race in the city, in the state of Florida. And, of course, Florida is hot and humid. So I live in Colorado, and I live at high altitude where it's dry and cool. And so I'm not used to hot, humid days. The day was about 85 degrees. That's not horribly hot, but it was humid. And I was sweating a lot. And now, many of you know that when you sweat, if you sweat for a protracted amount of time, then you will sweat salt. And so you need to have some salt. And by the way, when you hear the term electrolyte in relation to a sports drink like a Gatorade or whatever, it is a relation to the salts that are dissolved in there. Now, the word salts, you think of salt as sodium chloride, but chemist thinks of salts as any ionic compound. However, the most important one for your body is actually sodium chloride and actually potassium chloride. So they put this in water. So you didn't know this, but Gatorade is actually salty. A little bit of salt is in there. And so, of course, I was drinking it. This is actually a different race, I think. That's in Colorado. But I'm hot because, well, I have no shirt on, so it must be a warm day. And so I'm running the race. And long story short is I knew it was going to be hot and humid, so I was taking salt tablets. So in my little fanny pack, you can kind of see it. Actually, this was the actual fanny pack I'm wearing. Oh, yeah, it's interesting mixed story. In my fanny pack, actually on the bike ride, I kept these little salt tablets in my pocket. I would take them every X number of miles. I was pretty good about taking them and putting them in my mouth. And then, and that was good because I knew I needed extra salt because I would sweat out a lot of salt. Well, on the bicycle ride of the 112 miles, I was good. And then when I got to the run. Well, the run starts about noon. It's hot, middle of the day, and it's really hot. I mean, it's hot. So what I decided to do is at each aid station, they had these sponges, and they were filled with ice water. And what I would do is I would squeeze them on my head, and it would just cascade over my body, and it would be wonderful. The only problem is that on the run, I put my salt tablets right here in this pouch. And as this water reached this, of course, it dissolved my salt tablets. And like a stupid idiot, I did not take any more salt. And then about 8 miles into the run, I started cramping in my legs. The legs were like screaming Mimi. Ah! It was painful. And I realized that one of the telltale signs of having not enough salt, they call it hypotremia, is that you start to cramp. And I was cramping. And I had to walk. I was very bummed that I had to walk at this point of the race. I was hoping to run the entire race, but life was what it was. And so I realized I needed more salt, so I would stop and I would eat salt, lots of salt, and eventually I was able to run again. But you definitely need salt. Salt helps your muscles contract and stuff like that. Now, in the typical American diet, we have way too much salt. However, in an Ironman triathlon, it's sort of a different ballgame. All right. That was more on electrolytes. Okay. All right, there is a couple more terms. It's kind of a definitional day. Let's talk about a thing called a suspension. What's a suspension? Okay. Particles in a mixture that settle out upon standing. So if you have like this sort of yellowy, muddy water right here, it settles to the bottom, and that then is a suspension. Okay, it settles to the bottom. There's also something called a colloid, and a colloid is it's heterogeneous. We've talked about this. Heterogeneous means it's the same throughout. Hetero, right? Means, hetero means different. With particles sizing, actually this should say homogeneous. It's a typo. With particle sizing between those of a suspension and a solution. So we should talk about, let me go ahead here. Let's talk about, there's actually three kinds of things. There are solutions, there are colloids, and there are suspensions. Basically, the size of the particle that's dissolved, the solute, is very small for solutions. For colloids, they're in the medium, and for suspensions, they're big. Now, these pictures are way too big. Even this size, if on your screen, would be too big. But the idea is solutions are very, very small in terms of their size. Colloids, the particles of the milk that is in the milk are in the medium size. Now, you can't see the individual particles. Suspensions, sometimes you can see the individual particles. They're very, very small. But that's the difference, is essentially the size between the three. All right, so a suspension versus a colloid, there's a very cool thing called the Tyndall effect. Now, in the Tyndall effect, if the light can be scattered, let me change colors here. If the light can be scattered, you see this is someone's got a laser right here, and he's shining the laser through, and it scatters the light. But you see between here, you don't see the light. You don't see the light here, and you don't see the light out here. Even though it's actually coming out here, there's nothing for it to reflect off of. And so for a colloid, you can see the water. Okay, for a, or you can see the light. And if it was a solution, there would be no light. So this one is kind of, this first bottle, if you will, is slightly colloidic, we would say, and this one is definitely a colloid. Okay, but if I were to pass it through just a regular water, it would just give you clear light. You wouldn't see anything. All right. There's also something called, and the reason this is called the Brownian motion. The particles, let me go back to a different color again. The particles are randomly moving around, and as the light travels through there, it causes the light to scatter. All right? So, there is also one other thing called an emulsion. An emulsion is where you have a colloid of a liquid in a liquid. So if we take two liquids and we pour them together, mustard is a good example here. You pour these two together and then boom, they become a colloid. Two solutions of liquid in a liquid. Okay, so I believe that ends today's podcast. We're hoping you're having a great day. Bye.